In this video, we're going to be taking a look at the concept questions for kinematics. Question number 1 asks, when an object is moving and slowing down, are the object's velocity and acceleration going in the same direction or in the opposite direction? So if this person is running to the right and I want to slow them down, am I going to push them to the right or am I going to try to push them to the left and make them stop? I'm going to push them to the left. So their velocity is moving to the right, but to get it to go smaller, 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 I have to push to the left, accelerating them in the opposite direction. So when you want to slow down, your velocity will be one way, but your acceleration will be in the other direction. But if I want them to go faster, does that mean the velocity and acceleration are going to be in the same direction or opposite direction? This time they're going to be in the same direction. If I want to make this runner go faster, I'm going to push them in the same direction that they are moving. That means that their velocity is going to get bigger and bigger and bigger because the push, or the acceleration, is in the same direction. So when they are in the same direction, the object is getting faster. Two objects, one twice as heavy as the other, are dropped from the same height. If we don't worry about air resistance, which object hits the ground first and why? So this little video here is of a bowling ball and feathers in a giant vacuum tube, basically, and they're both being dropped. And the question is, well, which one gets to the ground first? And we can see that feathers and a bowling ball actually reach the ground at the same time when we don't have air to slow them down. And that's because gravity reaches up and grabs them both and pulls them down with the exact same amount of acceleration, which is 9.8 meters per second squared. The reason why that doesn't happen with feathers and a bowling ball if you were just to drop them normally is because air would slow down the feathers more than the bowling ball because the feathers have less mass and more surface area by just the fact that they're feathers. But if we're not worried about air resistance, and in kinematics we typically just don't worry about air resistance, then they would actually be moving at the exact same rate downward, which is negative 9.8 meters per second squared. But that begs the question, what exactly does meters per second squared mean? Well, if I have an acceleration of 10 meters per second squared, how does that describe my motion? Well, the first thing that's important to understand is that meters per second squared just means meters per second per second. Meters per second is a speed. 10 meters per second means I'm traveling 10 meters per every second I'm moving. But what does this extra per second do? 10 meters per second means that my speed is getting faster or slower 10 meters per second for every second that I have that acceleration. If we think about that in terms of your car, let's say that you're at a stoplight and you pull out with an acceleration of 10 miles per hour, that's your speed in a car, per second. Same basic idea, meters per second, miles per hour, but 10 meters per second or miles per hour per second. What exactly does that do? That means when you hit the gas and you have that acceleration, after 1 second, the velocity of your car is going to be 10. After 2 seconds, it's going to increase by another 10 to be 20. After 3 seconds, to be 30, and so on. As long as you keep that acceleration of 10, your speed is going to increase by 10 every second that you're moving. When you throw an object up into the air, what's the velocity and acceleration while it's moving up, which is right here, reaches its maximum height, and then while it falls back down? Well, when it's moving upward, the only force acting on it is the force of gravity. It is getting slower because eventually it has to stop going up before it can start coming back down. So the acceleration is downward because of gravity, but the velocity is still upward. Remember, one of the first questions we looked at were the velocity and acceleration being in the same direction or opposite directions. It's moving up, but getting slower. So the velocity is up, but the acceleration is down. At the very top, the acceleration is still downward, 9.8 meters per second squared, and it stops just for an instant in time. The velocity goes to 0 because it has to stop going up before it can start coming back down. As it comes back down, it gets faster and faster and faster, which means that the velocity is downward and the acceleration is also downward because it's always down 9.8 meters per second squared. Those are all the concept questions for kinematics. Hope that helps.